Our entrance question is asking us, if we know that triangle ABC is congruent to triangle XYZ, what 6 things do we know? Please pause the video, take a moment, and think about what 6 relationships we can come up with. Think relationships between sides and relationships between angles. I've drawn out triangles ABC and triangles XYZ. Since A is appearing as my first letter in the first triangle and X is appearing as the first letter in my second triangle, I know that angle A and angle X are congruent. Since B is the middle letter in the first triangle and Y is the middle letter in the second triangle, I know angle B and angle Y are congruent. And since angle C is the last angle in the first triangle and Z is the last angle in the second triangle, I know that angle C and angle Z are congruent. Since AB is the first 2 letters in triangle ABC and XY are the first 2 letters in triangle XYZ, I know that side AB is congruent to side XY. Since BC represents the second 2 letters and YZ represent the second 2 letters as well, I know BC is congruent to YZ. And since A and C are the first and last letter and Y and Z are the first and last letter, I know that side AC is congruent to side XZ. This video is going to take us through the beginning parts of proving triangles congruent. So we're going to take a look at a couple of congruent shortcuts that might make our proof process a little bit faster. When we say that 2 triangles are congruent, we are saying that all of the corresponding angles are congruent and all the corresponding sides are congruent. If we were writing a 2-column proof for this could take an awfully long time. So we're going to take a look at some shortcuts that will make our life a little bit easier.
Read this one first.
Here we have 3 toothpicks representing 3 different side lengths of a triangle. We're going to try to arrange these into as many different triangles as we can. But you'll see that the only way that we can arrange these is like this. There's no other way to create a different triangle with these 3 given side lengths. Even if we try to move it around and flip and rotate, we still end up with the same triangle. It's just in a new orientation. The video clip you just saw demonstrated the SSS, or the side-side-side postulate. If we know that 3 sides of one triangle are congruent to 3 sides of another triangle, then the triangles are congruent. So if we know that AB is congruent to DE and AC is congruent to DF and BC is congruent to EF, we can say that triangle BAC is congruent to triangle EDF. Notice the path that I took on the first triangle went across from B to A, going across the 1' side, and then across the 2' side. I need to match that pattern with triangle EDF going across the 1' side and then across the 2' side. The next video clip we're going to watch is a video where we're giving a partial triangle. The triangle has 2 given side lengths and 1 given angle that joins the 2 sides together. We're going to think about how many different triangles we can draw. Let's take a look at the SAS side angle side triangle congruent shortcut. You'll notice that I have 2 side lengths that are fixed together at a specific angle. There is only one way to complete this triangle, and that's by adding this side length in here. So therefore we know that if we know we have 2 congruent sides and 1 congruent included angle, we know we have 2 congruent triangles. So if we see the SAS, or the side angle side postulate, we know that we can show 2 triangles are congruent. So if we come across a triangle where we have 2 sides that are marked as congruent and their included angles are marked as congruent, we can say that the 2 triangles are congruent. So I could say that triangle ABC is congruent to triangle DEF. Notice the path we took. I went across the 1' side to the marked angle and then across the 2' side. I need to match that same path in the second triangle. The The last property we're going to take a look at is dealing with equal angular triangles. So how many different angular triangles can we draw? Well, we learned earlier this week, or last week, that an equal angular triangle has three angles that are each equal to 60 degrees. So here's my sketch here. Now this is not the only equal angular triangle that I could draw. I could draw a larger scale version of this where the three angles are still 60 degrees. Now obviously those side lengths are going to be different, so this is showing that if we know that we have three congruent corresponding equal angles, then this is not enough to show that the two triangles are congruent. We've talked about the reflexive property before, and this property says that something is equal to itself. A lot of times we're going to use this property if you come across a shape where they have where the two triangles have a shared side. So if I take a look at this top triangle here, triangle ABD, and this bottom triangle here, triangle BCD, I notice that they both share a side. The way I mark this as a shared side, I mark that as BD, and I can say that BD is congruent to BD. This might be helpful as we complete our proofs later this week. The first question asks us, which angle is included between side AB and side BC? So, to look at this, I'm going to go ahead and trace side AB and side BC. The angle that joins the two together is angle B, right here. Next, we're asked what angle or which side is included between angle A and angle C. Well, here's angle A, and over here is angle C. The side that's joining them together is side AC. Example 2 says that RE is congruent to CA, RD is congruent to CT, and that angle R is congruent to angle T. We want to know if we can prove that triangle RED is congruent to triangle CAT. First thing I like to do is go ahead and mark my congruence relationships. So RE is congruent to CA, mark those each with one dash. RD is congruent to CT, mark those each with two dashes. And that angle R is congruent to angle T. Well, if I look in the triangle on the right, triangle RED, I notice that I have two sides with an included angle, so that looks like SAS to me. But if we look at the second triangle, I see that I have two sides, and the angle is not joining them together, so this is not SAS. Since these two things are not the same, this is not enough to prove that triangle RED is congruent to triangle CAT. They might be, but there's not enough information at this point to say for certain. So they are not necessarily congruent. In example 3, we're taking a look at triangle LUZ and triangle IDA. We want to figure out how we know that these two triangles are congruent. Well, if I take a look at each triangle, I notice that they are both marked with a 65-degree angle, so those two angles are congruent. I notice that they're surrounded by sides that are marked as congruent. So since I have two sides marked as congruent in each triangle, and in each triangle I have one included angle, I know that these two triangles are congruent because of SAS. Let's try this out in proof form. We are going to use our triangle congruence shortcuts to prove that triangle CAR is congruent to triangle RDC. Just like all of our other proofs, we always start with our given. We're going to start with CA is congruent to DR, and the reason we know that is because it's given. As long as I'm writing it on my list, I'm also going to add it to my diagram, one dash on each. I also have that CD is congruent to AR. This is also given, and I'm going to mark these things in with two dashes. So CD gets two dashes, AR gets two dashes. If I look at these two figures, I notice that these two triangles share a common side. So I'm going to mark in that CR is congruent to CR. And remember, the property that says that something is equal to itself is the reflexive property. Well, if I look at triangle CAR, I notice that there are 3 sides marked as congruent. If I look at triangle RDC, I notice that there are 3 sides marked as congruent. So since there are 3 sides marked as congruent, I can say that triangle CAR is congruent to triangle RDC because of the SSS, side triangle congruent shortcut. Alright, now it's time to try it on your own. You're going to take a look at your textbook. You're going to read and take notes on section 8.1. And on page 409, you're going to try problems 1 through 16 and 18 through 20. We'll talk about any questions and issues that come up next time in class. Before you leave this session for today, take a moment and figure out which 3 congruent statements you can make about this figure that is drawn for us below. Thanks, and see you next time.